All right, so hey everybody again. Today we're going to talk about creating SQL databases. Now this again is optional for your projects. I will say it is always good to mention that you have a SQL database for your project because as I think some of you who have started to look at job descriptions, a lot of them do require SQL. So just having SQL as part of your project, even though you don't have like multiple tables and you're not doing like intense joins or anything, good to have just to show that you can work with SQL. To be honest, most of the time you're going to end up like, importing all of your data from the SQL database, like select star, and then just work out of pandas. But whatever, maybe for like your EDA, you decide to do it via queries. That will be a good way to just showcase that you are aware of how SQL works and that you are able to use SQL as well. Okay, so before I talk about the creating of tables, I'm going to talk real quick about creating schemas. There are several things that you can do. There are quite a few websites that do the same thing. So one of them is DB Diagram, where you can pretty much just create your own version of this chart. If you have one table, it is good to somewhere in your project write out what the schema is, because as you know, SQL databases are not like CSVs. They're pretty opaque in the sense of like, you don't know what columns there are until you like select star. So this, especially if you have multiple tables, a good thing to create. This is not the only website that does it. If you just look up like schema creating schema software or website, there are a bunch available. So this is one option. There are a bunch of others. If you have multiple tables, or actually, as long as you're doing a SQL database, you should have one of these. Cool. Other than that, unfortunately, I'm unable to demonstrate these, but there are a couple softwares that allow you to directly interact with your database. So two that I've used, and on this computer, I can't use it because they're like, Flatiron School doesn't let me download random third-party software, but I've used these two in prior projects, Mysql Workbench and dbeaver. These basically allow you to connect to your database or look up the database file, and it'll just pull up your database in like an interface like this. So you can actually see the data that you're working with, and you can check that your data is, there and correct. So dbeaver is one of them. Mysql Workbench is actually created by MySQL. So if you see like, let's see, we can see a screenshot of what it looks like. Yeah, kind of looks like this. You can like connect your database to it, or open your database file in here. You can actually look into your different databases. They'll show you the columns. You can actually test queries in both of these as well. That's nice. So yeah, highly recommend using either one of these. So now to creating these SQL databases, I'm going to talk through 2.5 ways to do this. So I'm going to talk through the very, very easy way to do this, which is actually just using pandas. And then I'm going to talk through the slightly more complicated way of doing it locally as well as on AWS. So again, at any time, feel free to interrupt. You all know how it goes. So we're going to use some sample data to just demonstrate this. Here I'm just using pandas, and I actually pulled this from one of the SQL labs. So in this example, I have a customer table and an order table. So let's just say that this is my data and I want to store it as SQL databases. So first, the easy method. The easy method is by using pandas toSQL method. In order to use this toSQL method, you actually need to import SQL Alchemy Create Engine. What that does is, you can sort of think of it as the module that helps you create the SQL database. So just follow this syntax. You can pretty much copy this if you'd like as well. You first have to create this. Now, it should start with SQLite : and 3 slashes, and then your database file name. So once I run this over here, oh, damn, sorry. Let me just quickly pip install. This is because I think a couple months ago, I like broke my environment and I haven't reinstalled everything I've needed since. Okay, great. Now that's done. Once I've created this, I want to show you all that a database file has been created. Let me find where that window is. All right, over here. So over here, you should see that. Okay, not yet, but so once I do this, and I create the SQL, and I'll talk about these in a little bit, but you should see a sales database has been created. All right, so after running that, here it's just a function. You don't need this to be in a function, but this creates a table where it takes in a data frame, a table name, and the engine. And the engine is basically this creator object. So I can just use this function to throw these data frames into SQL. So pretty much the syntax is data frame.toSQL and then these arguments. So over here, I'm just taking the customers table, which is this table over here, naming it customers, because for SQL, you need to have a table name, and then engine. Here I have an if exists equal to replace. So basically replace the table if it doesn't already exist. Other things that you can do, you can actually like append. So for example, if I change this to append, if I run this again, it'll just double all the rows. So depending on what you want to do, you can do different things using that same, this same toSQL method. Oops. All right. So just like that, I have appended 2 tables or created 2 tables. Now you see all of this output. All of this output, you can actually edit in the toSQL. So if you do df2SQL, oh yeah, hold on. That's not through df2SQL. Oh, here. When I do echo equals to true, so that's not from toSQL. Let me close that. So echo equal to true, what that means is it's kind of like verbose for a lot of the methods that we've been using. So echo equal to true is literally showing you what are the SQL queries or commands that are being used when I do any sort of action onto my SQL database. So from here, you can see that we are actually creating this table customers. We haven't really seen this syntax in our program yet, but this is the syntax for creating a table. You can see that it's actually a little bit time consuming, and we'll see this in a little bit as well. But here you can see that, all right, it takes in an index, customer number, customer name. It also tells you specific data types. And here we're inserting all of this in all of our data. So that's what's happening over here. Same thing for order details, which is this table over here. For order details, actually the same thing, creating this order details table and then inserting all of these values. So our SQL tables have already been created. All the data is already imported because I automatically threw it in from a data frame. So if I'm rereading in my data, if I'm doing select star from customers through engine.execute, and there are a couple ways that you can do this. I think the query, the way that it's done in the labs might be pd.read SQL. There's a different method to do that, but all the same. And you can see from here, I'm coercing this into a data frame, also giving it the right column names, and my tables are here. So let's just say I created this in this notebook. If I wanted to open it in a different notebook, I just have to use this engine. Any questions about this? This is like the easiest way to go about it. And I'll talk about some cons of doing it the easy way.
So this is just the customers database, right? It did not hook up the second database yet.
So this is the customers data. If I want to look up the other one, which is what did I call it? Order underscore details. It is in there already. So order details is here as well. So if I wanted to join order details, I could do the same. So if I do like, let's see, order details and customers. Cool. So let's just see, what can I join it on? I guess nothing. I guess I chose bad examples. But yeah, if I could join it, I can actually do my join statement in here.
Gotcha. Thank you.
You're welcome. Anything else? All right, so some quick cons about this. It's really only relevant if you plan on doing like consistent updates to your SQL database. But with SQL databases, and if you ever get more into SQL theory, by the way, on our homeroom, I've linked a Google Drive with a bunch of resources. I'll talk about that in a little bit. I'll link some courses that will help with SQL too. And when you do one of those courses, there are actually a bunch of rules that go around SQL. Like the way that you treat an index column is much more strict than how you treat them in a pandas data frame. The ways that you define data types can also be very strict. So when you're doing PD.2 SQL, this method kind of takes all of that for granted. So you don't have these things like primary keys, you don't have foreign keys, which are things that you can learn later on. So 2SQL is extremely simplistic, very, very prone to error if you plan on continuously updating your data. If you just need to do like a data dump into your SQL, this method would actually be perfectly fine and also a much more time efficient for this like very short project. Cool. Any questions before I move on to the next method? All right, so this next method, again, also optional, and this is really only if you want to be able to put like AWS on your CV, and which is always good to have, but you don't have to do it during the capstone for sure. We're going to talk through using AWS's RDS. So this is my RDS, and actually let me show you. AWS has so many different services. I don't know if any of you have like been in the realm of AWS, but AWS provides a lot of different things. So one of these things is relational database, a relational database, RDS. And RDS stands for Relational Database System. In some of my resources, I talk about using other AWS things, and that'll come later. So cool. Pros and cons of using these versus 2SQL. AWS RDS allows you to configure your database more professionally. So that con I talked about before, where you don't like define your primary keys, foreign keys, which right now might sound completely foreign to you all, but that's fine. And also some cons, it is a very, very manual process. So what I've linked here is actually a step-by-step on how to set up your database on AWS, which is actually, if you follow all of these steps exactly, and I actually just did this a couple hours ago, so I know it works. It should be okay. And what you end up with is a database that looks like this. So you can see I actually deleted all of my old ones. And now I have this one database over here that we're going to connect to. So once you are at this page, and by the way, the instructions will tell you exactly how you get here. AWS's documentation is usually kind of dense, but this one I think is okay. And any questions, feel free to let me know. So from here, things that you need to remember are your endpoint, because that's going to be like the URL that your Jupyter Notebook or whatever system uses to connect to this. If you decide to use like one of those other softwares that I talked about to connect to your AWS RDS, for example, like Mysql Workbench, or the other one is the dbeaver, they will also ask for these endpoints. So this is a very important URL to like copy and paste all over the place. While you're setting it up, by the defaults, make sure that it is publicly accessible. If this says no, all you have to do is go into modify, and then in modify, there is a place that you can toggle whether it's publicly available or not. And that is over, I think here, publicly accessible or not publicly accessible. All of these are pretty much the default. These are mostly the default parameters, but if it's not default, it actually shows you in that step-by-step walkthrough. All right, so coming back to this, a couple libraries that you're going to need. You need the Mysql connector. So Mysql and SQLite are kind of different flavors of SQL. The SQL that we've been dealing with so far, the stuff that we had in phase 1 was SQLite, because that is kind of like the Python native version of SQL. Mysql is a slightly different version of SQLite, but I would say that these two are the most similar to each other. Some other kinds of SQL, Oracle, the company has their own version of SQL. What's another one? Postgres, if anyone has come across those. That Postgres has its own flavor of SQL where syntaxes and like keywords are slightly different. But typically if you're going to a SQL interview, they'll ask you what SQL you're familiar with. And most of the time, these the main commands remain the same. So not a big deal either. So we're going to use the Mysql connector library to just connect to our AWS RDS. It's actually fairly straightforward as well. So once these are imported, you have to give it the endpoint, which is literally I copied and pasted that from my console over here, this over here. And then for username and password, I just put a testing password. But this is something that you will set up as you set up your database. So you'll know what the username and password is. Over here, I believe if I do, actually, let me just create a new one so you can see what that looks like. If I do create database, the first thing that you'll see is setting up the username and password. So you can do standard create, which is what the thing will walk through. So we'll do that. And then here you can see your username and password. So that's something that you will remember. Okay. So connecting to the database, it's very similar to what we talked about before, just that this is now on AWS. But we set up our connection, and then we have our cursor. Remember, the cursor is what allows us to interact with the database. So cool. For now, I'm just going to drop this database. And if there isn't one, you can see that if I run this again, there's an error because the database doesn't exist. I'm doing that because I ran all my code before and I had an existing database that I'm just getting rid of now. All right, so to create the database, these are some functions that I actually took off of AWS's documentation. They actually recommend that you use these. So this is here. So what we have here is a create database function that will create the database, or if there's an error, it'll tell you what the error is. And it takes in the cursor object and whatever the database is. And I think I have mine as, where is it? It is under DB name, I think. Let me look for where create database is. There we go. So what I'm doing here, run this function over here. We're going to do this try except. And you can see that the database still does not yet exist, and it creates this successfully. Any questions at this point? This just has created a database, but at this point, our database is empty. We haven't touched our data. We haven't let AWS interact with our data at this point yet. All right. So I like to think of this as like a 3-step process, any sort of database creation. One, you create the empty database. No tables are in here yet either. Next, you have to define the table schemas, and then you insert your data. Then after that, you can just query whatever. So because this process is kind of tedious, I only did it for one table, but just know that you can replicate this for multiple tables. And you'll see why I only decided to do this for one table, because it is very, very tedious. So to create this table, you actually have to create a string, a very, very long string that does the SQL command for creating a table. And this syntax might look kind of weird. So here you'll see that I instantiate an empty dictionary, and I'm creating this new customer key that has this command. And let me just run this real quick. And by the way, I just have this dot hit so that I can match the column names with each column that I'm creating over here. And then if you see here, this is what my create statement is. So basically for SQL, I'm creating the table customers that has all of these attributes. Now, for some reason, it doesn't work in a docstring. I personally don't know why that is either, but it somehow works with this like tuple of many one-line strings. I don't know why this works and not a docstring. I tried it with a docstring, it did not work for me. But you need all of this. I'm also not 100% sure what this engine thing is, to be honest, but this is a syntax that works. So it's just the name of the column that you want. Oh, also super irritating, but you have to have that space at the start. It like messed with my OCD, but you need that for some reason. You need the column name, the data type that's going into that column, and then usually not null. Or if you are allowing for null values, you don't have to have the not null, but I usually do not null because I don't want any nat values. What these are, integer 11 means that it takes an integer of up to 11 digits. Varchar or variable character, basically like a string or an object, but up to 64 characters here, up to 16 characters here. Phone number, address, yeah, integers. You can also do floats. So yeah, you basically have to do this for every table that you want to put into your AWS RDS. So this can be a very, very time-consuming process if you're typing every single column out. So I should have picked a smaller table, but whatever, this is here now. Questions about this?
So
Yes.
varchar is specifically for characters and integer float is for numbers. You can't use varchar interchangeably for numbers.
Well, the thing is, you can use varchar for numbers, but when you read it in, it'll read it as a string.
Right, yeah, and then you'd have to reconvert it. Okay, gotcha.
Yeah, so maybe you want to do it all varchar because you know you can do it in pandas later, but I don't know, might as well. Cool. Anything else? All right, so if you had multiple tables, you would do this multiple times so that you have like a whole dictionary of commands. But at this point, I only have this one. So if I actually take a look at what tables looks like, tables would be, all right, to create customers, run this command. All right. So now if you remember, we've already created our database. So now with this new connect, and something that is kind of annoying with Amazon is that the connection tends to drop, not to a point where you can't work, but it's good to always have this. You might have to rerun this cell over and over again. And you'll see that I actually have this cell copied every time I want to do an action that does some sort of editing onto my database. So the only thing that I'm adding here is now that I know that I've created my database sales, I'm going to interact directly with my sales database. Now when I do this, I have my cursor running, and then this is going to create my tables. So for table name and tables, this is going to basically run through every key in my tables dictionary. I'm going to do cursor.execute the description. So the description is basically this command. If I do this, you can see, all right, it's creating the table customers. Okay, cool. And every time, and this is a really good practice to do as well, every time you do something that you can think of it as like a save point, you do cursor.close and connection.close, just so that you're not consistently connected to your database. I like to do this out of, I don't know, for peace of mind, honestly, if anything. You see, if I run this again, this doesn't work because the cursor is not connected because I've already closed it. And if I run this one more time, you see that the table already exists. So that table is already in there. But at this point, I only created the schema. The table at this point has no data at all. So this is the second part. Any questions at this point? Okay. So, all right, let's take a look at our customers columns. These are the columns that I have. The insert statement. So there are two ways you can insert data, one at a time or a bunch at once. I'm going to show you all one at a time first, just in case you need to update your data with something. And then I'll show you how to do it all at once. But the syntax is a little bit annoying. So this is normal SQL syntax. If you were to type it in like multi-line, again, I'm using that same syntax of doing the strings within a tuple. So here, this is my insert statement. And what this means is I'm inserting into customers these values over here, these values. And what this means is it's actually very similar to a format string. This is actually how old Python used to do F strings, format strings. So what this %s means is it's going to take in, what is it? I think it's 11, 12, 13. I think this is 13 different strings. And you'll see where this comes into play. So this takes in variable values. So here I have this insert statement that looks like this. First, I'm going to drop NA to make sure I'm not inserting any values, and I'm going to turn everything into a string. So at this point, all of these values are strings. Just for simplicity's sake, these are all strings now. And the way that this is inserted, one row at a time, we're just taking the values as a tuple. So, all right, so I'm just going to define my first row of values as this tuple over here. And I think, is it 1, 2, 3, or 5, 6, 7, 8, 9, 10, 1, 2, 3, 13 values here. And these are going to match these over here. I know that I did not say very many coherent English sentences, but hopefully that made sense. Any questions about what I'm doing here? You're setting up this command as well as this data. Okay, so before I run this, again, we're connecting to the database, giving us our cursor, and to execute our insert statement, we're executing the insert, and the insert, remember, has these variable s, that variable s line, and then I'm giving it the first. So it's taking in this tuple of values. So once this is done, you'll see that it is inserted. And if I actually read in the data real quick, and I think this is the one. This is one over here now, and this is just connecting directly to the database and reading everything from customers. I have my first row of data successfully inserted, just like that. All right, so that's inserting one row. You're probably more interested in inserting multiple rows, so we'll talk about that. So to do that, pretty much all of your data still has to be in tuple form. So what I'm doing here is I'm doing a list comprehension that turns each row into a tuple. So if I look at the full data, it's actually a list of tuples. So with this list of tuples, the only difference here now is that instead of execute, because remember here is cursor.execute, instead of that, it's just changing it to execute many, where data can be a list of the tuples. So likely you're going to do something like this instead. So with this line, again, same, connecting my connecting to the database, getting my cursor, executing many, commit, and then close. So just like that, if I rerun this, you'll see that, of course, it's just adding in rows. So the first row, because we added it once before, is duplicated. But now we have our 10 rows of data, just like that. Any questions about this? All right, so if you take a look at this,
So
and I
I
think if
have
I
a
do,
question.
yeah, go ahead.
So when you, I guess, instantiated the SQL database and you declared like the table with each of the column names and you had the variable types.
Mhm.
So why, I mean, why do you do that at all when further down, when you're inserting the data into the frame, you put all strings, you entered it all as strings, and then when you come back to, and then when you recall it from the database into a pandas data frame, they're all strings, right? So
Why
I guess
do
I'm
this,
wondering
right?
why you do that part or why you make the distinction of it when you're creating this tables customers, like why you declare different variables when later on you enter them all as strings.
Yeah, that's a great question. So the reason why this has to be declared, and the reason why, actually, no, before that, the reason why this has to be converted into strings, where is that converted into strings? Wherever that is, the reason why I have to convert that into strings is because SQL by itself reads strings. So what's happening with a cursor is it's actually taking this and translating it into SQL and then feeding it into to interact with the SQL database. So it's pretty much only because we are interacting with it through Python that we have to first convert it into strings so that it can create the command the way that we want to, if that makes sense. And so automatically when we read if we were to look at this data again and read this data back in, it should follow these data types, if that makes sense. So basically, the reason we're turning it into strings is so that we can format the command, not the data itself. Is we're formatting the command to insert the information into the database, and then when we read it back in, it should be like integers and strings. Actually, let's try that out. I've
So
never actually tested.
So in this pandas data frame down here, you're saying that these aren't all, it's not all strings. It's been read back as.
Yeah, so you can see here
okay.
we have our integers and yeah, our integer types. Yeah, that's a good question because yeah, it is kind of like why are we doing that? Is really just so that we can format this command properly. Because this, I would say this is actually easier because %s is actually looking for string imputation. There are different ways to do it. I think if you do like $d, it will specifically be for a number, but then there's no neat way to do it such that, all right, I know that columns number 3, 4, and like 11 are digits. So then I would have to like be careful and do like, all right, D for this one, D for this one, so on and so forth. So it is overall simpler, I think, to have this all as %s because you just have to count the number of columns that you have, turn this all into strings so that when you impute these values into the query, it won't break. Yeah, that was a good question. Yeah, anything else? All right, well, if any of you are looking to build or store your data in an AWS RDS, let me know if you're running into any issues. I actually ran into one issue earlier today when I was resetting this up. I don't know if it has to do with like my IP address, but oh, by the way, these are the instructions on how to do that. I ran into one little problem. I don't know if it's because of if it's like my if it's my IP address or because I'm on like a company computer, but I had like a timeout error. And if you're getting something like that, let me, because I know how to fix it now. Cool. Let me, any questions about this before I stop the recording? And then we'll do some open office hours for the rest of the hour. All right, let me stop it here.